Welcome back, everyone, to another explainer. Today, we're taking a really fascinating deep dive into a system that solves, honestly, one of the biggest headaches in the digital age right now. We're looking at exactly how data access is protected, precisely metered, and accurately monetized. We are talking about the Codatta Access Gateway and Metering Framework. So, if you've ever wondered how the mechanics of data ownership actually work under the hood, well, you're absolutely in for a treat. Think about this for a second. How do you guarantee a data creator gets paid every single time their work is used? I mean, just think about the sheer chaos of unmetered data sharing today. It's a massive black box. Files get copied, queries are run, massive AI models are trained, and the original creators, they're completely left in the dark. Well, the Codatta Access Gateway is pretty much the ultimate solution to this. It acts as this super intelligent layer that decides exactly who can read what, how much they can read, and under what conditions. And ultimately, it turns those reads into cold, hard billing events. Okay, let's dive right into this and map out our exact factory tour. We're going to cover 1, the gateway big picture, 2, the anatomy of a policy, 3, serving with strict obligations, 4, metering and generating the receipt, and finally, number 5, ironclad audits and replays. Let's get going. First stop on our tour is section 1, the gateway big picture, from request to royalty. Now, I want you to think of this gateway not just as like a bouncer at a club, but more like a highly intelligent customs agent at an international border. It doesn't just glance at your ID, it asks exactly why you're here, what you're carrying, and it tracks everything you do while you're inside. So here is the chronological pipeline of a single client request, right from the very moment it knocks on the gateway's door. Step 1 is the request. The client walks up with their identity, their license, and their intended purpose. Step 2, the decision. The gateway runs a comprehensive policy check. Step 3 is serve. If you're approved, the bytes or the results are served up from storage or a secure environment. And finally, step 4, and this is the magic part, is meter. The gateway emits a cryptographically signed, version-pinned event that heads straight over to the royalty engine. Every single request goes through this exact pipeline. So, how does our digital customs agent actually make that decision? That brings us to section 2, the anatomy of a policy. Basically, the gateway's brain. The system uses attribute-based access control. Now, that's really just a fancy way of saying it runs through an incredibly detailed checklist before it makes a single move. It's evaluating 4 main things. First, the principal. Who's asking? It checks identity, KYC verification, reputation tier. Second, the resource. What do they actually want? It checks the specific dataset ID, the exact version, and its sensitivity. Third, the action. What are they doing with it? Is this a quick read, a sample, a full export? And fourth, the context. Time, region, the purpose, like is this for academic research or commercial use? And of course, what's their budget? It evaluates all of these variables at the exact same time. And what happens after that evaluation? Well, it's not just a simple yes or no. If the gateway issues a deny, it isn't just tossing you a blank error screen. It gives you an explainable denial, citing the exact rule and the reason you got rejected. But here is the really brilliant part. Allow with obligations. The gateway can basically say, yes, you can access this data, but with some very strict strings attached. These obligations might require specific actions to happen before you ever see a single byte of data. Which perfectly tees up section 3, serving with strict obligations. This is all about enforcing those rules in real-world execution. Real quick, before we look at the specific obligations, let's talk architecture. To make sure data disclosure is kept to an absolute minimum, the Codatta Gateway leverages a TE, that's a trusted execution environment. This basically ensures that highly sensitive raw personal information can be processed to answer a query without ever exposing the underlying raw data to the person asking. So, what do these obligations actually look like in practice? Well, the gateway can enforce minimal or selective disclosure, meaning it requires specific credentials instead of just handing over raw PII. It can enforce field-level masking, literally redacting specific columns in a database. It can force the return of only aggregated data. For users who just kind of want to look around, it enforces sliced sampling, so they only get a representative slice unless they pay up for a higher tier. And importantly, it can enforce hard quotas and rate limits to throttle usage, flag outliers, and prevent abuse. It is an incredibly dynamic defense mechanism. Next up is section 4, metering. Generating the receipt and tracking every single byte. Now, what's really interesting about this step is that it's where the entire system proves its financial worth. This is where a permitted read transforms into a rock-solid digital receipt. Think of a version-pinned metering event as the ultimate, itemized receipt that feeds the royalty engine. It captures the who, the requester and their payment account, the what, the dataset ID, and, crucially, the exact version, the how much, tracked down to the very rows, gigabytes, or seconds used, the when, a strict timestamp, and the why, which specific policy rule was matched to allow this in the first place. All of this gets bundled up with a gateway signature, making it a totally verifiable proof of usage. But how does that receipt actually get paid? The gateway supports 3 distinct payment modes. You've got your standard license, which is typical pay-as-you-go where usage settles against a revenue account. You've got prepaid, which simply subtracts from a balance of credits. But the most revolutionary mode here, by far, is the middle one, TNPL. TNPL stands for Train Now, Pay Later. And guys, this is a literal game changer for AI developers. It works exactly like a commercial line of credit. Builders can access the data they need right now to train their models, and they just accrue deferred obligations. They only settle the bill later when their AI product actually starts generating revenue. It completely aligns the cost of high-quality data access with the actual profitability of the AI model. It's just a brilliantly frictionless way to foster innovation without bankrupting creators up front. Moving on to our final section, number 5, ironclad audits and replays. Because all this tracking is great, but why should data creators actually trust it? I want you to focus on this number right here, 1. It represents the absolute mathematical precision of the Codatta framework. If you have exactly one set of inputs, meaning the exact same request, the exact same policy version, and the exact same dataset version, the gateway must always return exactly one identical decision and generate one identical payout calculation. Zero room for ambiguity. None. And this brilliantly illustrates the core guarantees of the system, what they call system invariance. Number 1, it's explainable. Every single decision cites a rule. Number 2, it's deterministic. Replays will always perfectly match the original outcomes. 3, it's traceable. Every single byte ties directly back to a specific asset. And 4, it's tamper-evident. All events are cryptographically signed. If there is ever a dispute, these invariants guarantee it can be cleanly resolved. Nobody gets cheated. So the crucial point is summarized perfectly in this quote from their documentation. Because events, ownership, and valuation are versioned, payouts are deterministic and explainable. That one word right there, versioned, that is the anchor of the whole shebang. Because everything is stamped in time, you can always look back and prove exactly what happened, why it happened, and who owes what. It really brings total fairness to the data economy. So I'll leave you with this final thought to ponder. Is your data access this explainable? If you're sharing data or consuming it to build models, are you operating in a black box? Or are you backed by a tamper-evident framework that guarantees fair compensation? The Codatta Access Gateway proves that a transparent, auditable future for data is entirely possible right now. Thanks so much for joining me on this explainer. Keep learning, stay focused, and I will catch you on the next deep dive.